Hi everybody, today we're going to be learning about negative exponents. Negative exponents may not be exactly what you think they are. Although the term says negative, it doesn't necessarily mean your answer is going to be negative. So make sure you pay close attention to what we're going to be learning about today. Let's go ahead and start with this following table. We're going to go ahead and complete it. In the first step, we're going to go ahead and write down the decimal value of each exponent. Then we're going to write that in fraction form. Then we're going to rewrite it as a positive exponent with a base of 10. If we look at the first one, it's pretty simple because what we've done is we've taken 10 to the third. We've already written it as a positive exponent because it's already in that form. But let's go ahead and write it as a decimal value. Remember, 10 to the third is 10 times 10 times 10. And we know 10 times 10 times 10 is actually 1,000. Notice the 3 zeros here in 1,000 match up with the 3 zeros here in the 10 times 10 times 10. So now for the decimal value, I'm going to go ahead and write 1,000. In order to write that in fraction form, anytime we write a number like 1,000 as a fraction, all we have to do is put it over 1. So there's my fraction form. Let's go ahead and do the others. 10 to the second is 10 times 10, which equals 100. Once again, 2 zeros match in the 2 zeros in the tens. So I'm going to go ahead and write my decimal value of 100. Fraction form, I go ahead and just write that over 1. And our 10 to the second is already in a positive exponent. 10 to the first. 10 to the first is just 10. And we know 10 equals 10. So our decimal value is 10. To write that in fraction form, I just go ahead and put that right over 1. And it's already a positive exponent. Let's look at 10 to the 0. Try to recall what that rule is for any number raised to the 0 power. Hopefully you remember that it's 1. So 10 to the 0 is actually 1. And how I write 1 as a fraction is just by putting it over 1, just like the other numbers. So 1 over 1. Ooh, something different going on here. We got a 10 to the negative first. Never really seen a negative exponent before, but let's try to look at patterns that we see in the numbers we've already written. Notice that when I start up here at the 1,000 and I go to 100 and then I go to 10 and then I go to 1, each time I'm actually dividing by 10. So now in order to get to my next decimal value, all I have to do is take that 1 and divide it by 10. So over here on the side, I'm going to do that. I'm going to say 1 divided by 10. Now remember, when we work with numbers, we have to skip, flip, and multiply. So I'm going to go ahead, I'm going to skip, I'm going to flip, and I'm going to multiply. And we know if I multiply straight across, 1 times 1/10 is actually 1/10. So there's my fraction form, 1 over 10. Ooh, but how do I write 1/10 as a decimal? Well, it's 0.1. Remember, that first place is the 10th place. So that is 1/10 as a decimal. Now, if I want to write that as a positive exponent with a base of 10, I know that if I take my fraction 1 over 10, how can I make that 10 an exponent and yet keep that base at 10? All I have to do is put the 1 there. Isn't 10 to the first technically 10? Yeah, so 1 over 10 is the same as 1 over 10 to the first. So once again, that negative exponent is now positive. Let's look at 10 to the negative second. If I continue this pattern and I divide again by 10, and I start with 1/10, and I divide that by 10, I skip, I flip, oh, I'm sorry, let me erase. Oops, I didn't flip it. I said it, but I didn't flip it. And I multiply. I multiply straight across. 1 times 1 is 1, and 10 times 10 is 100. So I'm going to go ahead and write that as my fraction form, 1 over 100. I write 1/100th as a decimal, 0.01, because that's the 10th place, and that's the 100th place. Now I want to rewrite that as a positive exponent. So how would I write 100 with a positive exponent and a base of 10? Well, isn't 10 times 10 100? Isn't that 10 to the second power? So isn't 1 over 100 the same as 1 over 10 to the second power? It is the same. Before we move on, I want you to notice something. Notice over here, when my exponent is a negative 2, in order to make that a positive 2, what do I have to do with it? I put it under 1. Look over here at the 10 to the negative first. In order to make that a positive exponent, I put it under 1. So that's something to remember in the future to make the rule work and go faster. So let's look at 10 to the negative 3. Once again, if I follow my pattern and divide by 10, I know that 1/100th divided by 10 is actually 1 over 100 times 1/10, or 1 over 1,000. So that becomes my fraction form. Now, also I want you to notice that, let me write that one again, sorry about that. Also notice 1/1000th is written as 1.001, tenths, hundredths, thousandths place. Now, if you look at what I did in the last two, in order to make that a positive exponent, I just have to put it under 1. And there it is. 10 to the third is the same as 1,000. So 1 over 10 to the third is the same. Let's try to work on some individually. Here's our negative law of exponents. Just so you know, any number raised to the negative exponent, in order to make it a positive exponent, I have to go ahead and put it under 1. If I'm going to fill that in with numbers, say 5 to the negative third, as soon as I put it under 1, it becomes a positive exponent. And 1 over 5 to the third is the same as 1 over 125. Notice, though, that on the bottom, it says 1 over 3 to the negative second. Notice when the negative is on the bottom or the denominator of my fraction, in order to make it positive, all I have to do is take that denominator and make it my numerator, and it becomes a positive exponent. Because if I put that over 1, that is my numerator. So when I have a base with a negative exponent in the numerator, I move the base to the denominator and make the exponent positive. If the base with the negative exponent is the denominator, it moves to the numerator to lose its negative sign. Now let's try this one to prove it. If I have 1 over 5 to the negative third, in order to make that a positive exponent, we talked that we have to put it under 1. So if I go ahead and do that and make it a positive exponent, I have 1 divided by 1 over 5 to the third. So let me write that out horizontally. When I divide fractions, I go ahead and skip, I flip, and I multiply. Anything times 1 is itself. So 5 to the third over 1, which is 5 to the third, times 1 is itself. Ooh, look, it matches what I got up here. So that's why all I have to do is take that negative exponent when it's a denominator and bring it up and make it my new numerator to make it a positive exponent. Your turn. This is what I want you to do. I want you to go ahead, pause the video, and try these on your own. When you are done, I want you to come back and check your answers. Hopefully you pause the video, so let's check our answers. 5 to the negative second. Once again, we said to make that a positive exponent, I put it under 1. So 1 over 25. And I have to evaluate it because it tells me to in the question. So 1 over 5 to the second is equal to 1 over 25. Let's look at the next one. Ooh, notice the parentheses around the negative 5 on my base. Once again, to make it a positive exponent, I have to put it under 1. But notice what changes. The negative in front of the 2, not the negative in front of the base. That stays with that 5 because it's inside the parentheses. So now I have to rewrite this as 1 over negative 5 times negative 5. And we know a negative times a negative is a positive. So this answer is 1 over 25. Let's look at the next one. Next one, my negative sign is on the outside of the 5. So it's really not attached to it. This really says negative 1 times 5 to the negative second. So the first thing I'm going to do is rewrite it as a positive exponent. So I have negative 1 times 1 over 5 to the second. Now if I multiply straight across, I realize that anything times 1 is itself. And a negative times a positive is a negative. So my answer becomes negative 1 over 5 to the second. And because it says to evaluate, I know that 5 to the second is 25. So this is negative 1 over 25. Hopefully you got those right. Let's try some more. I want you to go ahead and pause the video, try these on your own, and then come back and check your answers. Hopefully you paused the video and you tried them. So now go ahead and check your answers. Here they are. For the first one, I have 1 over 49. Second one is equal to 49. Third one is equal to 1 because anything raised to the 0 power is 1. And the last one is a positive 49 as well. If you have any questions, try to refer back to the notes section of this video. Now I want you to go ahead and evaluate this. This is 3 times 2 to the negative 4th power. I can go ahead and rewrite this as 3 times 1 over 2 to the 4th power because I want to rewrite it as a positive exponent. There's no way I can figure that out with that negative exponents being there because I have no idea how to evaluate that. So now I'm going to go ahead and I'm going to multiply straight across. I now have 3, I'm going to make it into a fraction, times 1 over 2 to the 4th. Well, this simplified 2 to the 4th is equal to 2 times 2 times 2 times 2. So 3 over 1 times 1 over 2 times 2 is 4 times 2 is 8 times 2 is 16. And that is equal to 3 over 16. So that would be my answer if I were to evaluate that problem. Now what I want you to do is go ahead and try these next two. Let me know if they're positive or negative. Be careful. Make sure you look at those parentheses before you try the problem. So pause the video, try them, and come back. Here's what you should get as your answer. For the first one, negative 3 to the negative 2nd power, try to remember that that negative sign is not connected with parentheses. So it has to stay with the problem. Notice that it does. So this answer will be negative. Let's look at the next one. Notice that the parentheses are around the negative 3. That means that they have to stay with that negative 3 when I'm multiplying. And we know a negative times a negative is a positive, so your answer on this one should be positive. I want you to ask yourself, where might you see this in the real world? Because that's what we always do in math class. When am I going to use this? Well, in this situation, science is a really big field where you're going to find these negative exponents. Have you ever heard of things like nanotechnology? Well, nanotechnology includes atoms and molecules and very, very, very teeny tiny things that you can't even see with your naked eye. So this is what you have to do. You have to look at these numbers up here on this chart. Notice when we start dealing with atoms and molecules, which you will learn about in science this year, those exponents are negative. But notice they still have a length to them, so the length is still a positive. So even though they have negative exponents, it only means they're teeny, teeny, tiny numbers. It doesn't mean that their lengths are negative, because we all know lengths can't be negative. Now what I want you to do is go ahead and answer your focus questions. Bring them with you to class tomorrow, and we'll go over them. See you tomorrow in class.